Hello, everybody, and welcome to episode 145 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, that is Gavin and Fia. And have you guys ever been, taken back by something somebody has said?
Oh, for sure. Like, almost every time I talk to you.
Yeah.
I know, right? So, tables got turned on me at some point. I believe this is the first podcast we're recording since I've gone back to school.
Yeah, I think so.
I'm a teacher. Yeah, I'm a teacher for the record. All right. For those of you that don't know. And first full day of school, there's like a little half day at the beginning, but the first full day of school, I've got these kids. We're doing geography, and we're doing Atlantic and Pacific, real basic stuff. And we get to the Great Plains, and I'm like, no one lives here. And I look at my students, and I'm like,
hey, I lived there.
Look
I lived there.
Look it. Oh, do you still live there?
No, but I know.
Rest my case.
I know many people that do.
Oh, really? Name 3.
Let's see.
Not the point. So we're moving on. Now,
okay, sure.
So I look at I'm like, has anybody been to any of these states? And I look around the room. Crickets. Nothing. Which is exactly what I'm expecting because no one lives there. And then all of a sudden, girl I don't even know because it's the first full day of classes. I don't know who these kids are. She raised her hand and goes, "Oh, my dad goes to Nebraska a lot for work." I'm like, "Oh, that's cool. What does he do?" And she goes, "Well, actually, I think he's just going there to cheat on my mom." And I'm like, "Whoa, whoa!"
Oh my gosh, what?
Wasn't ready for that. I was not prepared for what was going on there.
Yeah, how do you
Why
even handle
Nebraska?
something like that as a teacher?
I heard that, and I was just like, "Oh boy!" I don't even know your name, but we've got some damage to unpack this year.
So, Lincoln and Omaha are actually pretty cool cities.
I've heard nice things about those places.
So there are cool places in Nebraska, and there's there's lots of excellent fossil sites in Nebraska, but one particularly great one called Ashfall Fossil Beds. It's from around the same time that my master's research location was from. So similar times, similar sort of areas. So maybe not a lot of people, but a lot of good fossils.
And that's all you need to keep you company.
Good. I'm glad there's something there for people.
Yeah. But wow, it's a tough go of the first week.
Honestly, it's part of what I missed. When you're not in school for a while, and I say this all the time, when you're hanging out with adults, it's boring as all hell. People are talking about their stupid kids. People are talking about sports team. It's the same conversations. The weather. You don't get conversations like, "Oh yeah, I'm pretty sure my dad's going on work trips to cheat on my mom," from people you don't even know. Part of the reason why I love this job.
Just why Nebraska?
What do you have against the women of Nebraska?
I mean, there's nobody there.
Or
You
men
said
of
it.
Nebraska, who knows?
That's fair.
You said nobody's there, so I'm confused.
So that way nobody finds out, I guess. I don't know. That's actually a good point.
Anyway, shifting topics entirely.
All right.
We have a wonderful guest, not here on the show, but in my house. Number 1 fan of the pod, Molly Hotchkiss, my mother-in-law.
Wait, Molly's here?
Yes.
You're just telling me this now? We were talking for 10 minutes before?
I did ask if she wanted to say a few words as number 1 fan. She declined politely.
No, Molly.
I know Liz really wanted her to, but no, she said she would get nervous, so she politely declined. But number 1 fan of the pod here.
I want to do the normal thing where I make fun of Molly and call her a coward or something, but she's so incredibly nice.
She really is.
I can't even bear myself to do that. Molly, we miss you. Come on the pod sometime.
Yeah, the next time she's in Pennsylvania from California.
So in 3 years.
Book it.
Yeah, who knows?
The next time you're in California.
True.
We'll probably go in the summer sometime. Next summer.
California summer?
I mean, where Liz is from and where her parents live is pretty cool, year round.
Nice.
Yeah, they're pretty close to the coast, so there's always a nice cool ocean breeze. I honestly think it's hotter here in Pennsylvania during the summer, or especially more humid, than where they live, at least in California.
Mm-hmm.
But we're the for spoilers for the kind of person I am, for the next 2 years, the Pokemon World Championships are in California. This coming year, in 2025, they're in Anaheim, so like around Los Angeles. That's where like Disney World or Disneyland. Yeah, Disneyland is in Anaheim. And then 2026, it's in San Francisco. So I'm hoping to go one of those 2 years, but we'll see.
That would be cool.
Yeah.
Beyond brand is what it would be.
Yeah. Anyway, however many minutes into the podcast we are now, this is a paleontology podcast. Once again, as per usual, you wouldn't know that from the first 5 minutes. We should probably do a little better branding on that front. But
I said the name of the podcast.
That's a little bit our shtick, though. But yeah, so we have a really interesting episode today. In honor of it being an episode that ends in 5, typically this would be a Fia Takes the Wheel. But Fia is, busy doing a PhD. So, has too little time to deign to spend on our little podcast.
I have a question.
I'm still here.
What does PhD actually stand? Like, I know it's doctorate, but like, what is PhD?
I'm pretty sure it's Doctor of Philosophy.
Yeah.
But they do it sort of backwards because Latin.
It's like MD, like medical doctor. But
I mean, now's not the time, but this, like, I don't know.
And then
not a fan.
The H is lowercase.
Yes. But yeah, so Fia, is here, graced us with her presence, but said she didn't really have the time to prep an episode today. So what I decided to do is sort of in honor of it, typically being a Fia episode, was talk about swamps in honor of Fia's former segment, the Swamp Corner.
Thank you so much.
Absolutely. So we're going to be talking about swamps. What exactly is a swamp? And then talk about swamps through time and how swamps sort of differ from other types of ecosystems. So that's going to be today. Before we get into that, Fia, do you have some housekeeping for us?
Oh, I do. Like always, don't forget to rate the show on whatever platform you listen to us on, and to follow us on Twitter, Facebook, and YouTube to give us feedback about the show and any future topics you would like to hear on the pod. And if you would like to be a guest on the show, hint to maybe some of our new listeners, be sure to fill out our guest form, and all that stuff can be found in the show notes. And then, Gavin, what is next episode topic?
It is going to be a surprise, but not because I don't know, but because I don't want to spoil it.
Okay.
Yes, I do know. I know sometimes I don't, but yes, in 2 weeks we're going to have a surprise topic. Maybe a little more toward Mike's alley, since this one's a little toward Fia's alley.
Do Mike and I get to know?
I mean, when we get done, I'll tell you.
Yeah, sweet.
I might want to be surprised, actually. Like, if the listeners are going to be surprised, I feel like I should be surprised too.
We'll see. I might want your help for a little bit of it.
Also, just like to piggyback on what Fia said, like, because I know Gavin showed us a chart, like some new people are listening.
Yeah.
First off, like, that's cool. But second off, if you like, either you know what you're talking about with some paleontology stuff, or you've got some questions, or you're just like a fan of the pod and want to come out, like, fill out that form. Like, we'd love to have you on. That's not a joke. That's not like fill out the form.
Yeah. So something else. So we got a couple of comments on Spotify, which is a thing that you can do. Like, I somehow knew in the back of my mind that is a thing you can do. Not just like leaving voice mails, basically, like my former master's advisor Darren did once. But no, like actually,
that was awesome.
It was pretty great. We then had him on the show as a guest. But so we had a couple comments, interacting with us on Spotify, and that was really great. I love interacting with the relatively small, cool community that we have here around the show. But yeah, so feel free to leave us some more messages. That was really, fun and exciting for me to read. Cool. But with the house kept, Mike, what happened today? What happened today in history?
So there was a couple different things here. There was a couple not fun stuff. Looking today in history, there was some Hitler stuff. There was some blackface stuff. Yikes. Decided not to go with any of that.
Thank you.
Yeah. So instead, I'm going to present this neutrally, and I imagine Gavin may have a snarky comment
Okay.
on this. But today in 1947, President Harry Truman officially establishes the Central Intelligence Agency.
I mean, I don't have any particularly strong feelings either way about the CIA.
Okay. I guess I'm a little bit surprised to hear that given your brand, but fair enough. Yeah, it's there.
I
Some
mean,
good stuff. A lot of bad stuff.
I'm sure, yeah, exactly. It's like they do a lot of good stuff. They do a lot of pretty shady stuff.
Do a lot of stuff that I have no right. I imagine a lot of
Exactly.
what they do we don't know about, and
Exactly.
that's kind of by design.
Like, is it a net good? Probably. I feel pretty confident saying, yeah, the CIA is probably a net good. But cool. So CIA.
Net good for who? We'll talk about that some other time. Or actually,
Yes.
no, we won't. Probably won't ever.
You're right, because then we won't ever be heard from again. That's how the CIA works. But cool.
But yeah, Harry Truman, 1947, CIA.
Awesome.
That's today in history. Now, Fia, Seagrass Corner?
Oh, yeah. Today on Seagrass Corner, I wanted to talk about the stone crab. Specifically the Florida stone crab.
Okay.
Well, I guess it's also known as the Florida stone crab, but the scientific name is Menipi maricinerea, I think. And
Not a real name.
That sounds good.
Maricinerea. M. maricinerea. The stone crab can be found on the western North Atlantic from Connecticut to Colombia, including Gulf of Mexico.
Oh, wow.
Belize, Mexico, Jamaica, Cuba, the Bahamas, and the east coast of the United States. They can be found in salt marshes in South Carolina and Georgia, too. And so the stone crabs are a big fishery in Florida. Stone crabs are different from blue crab fisheries because they don't actually take the whole crab. They just harvest the big claws, like the arms.
Like from SpongeBob, the big meaty claws.
Big meaty claws. Exactly. So there's a bunch of rules and regulations on that to make sure that they, survive afterwards. But I wanted to talk about...
'cause I forget that that's a thing that a lot of arthropods can just do.
Yeah, they can grow back their arms.
Like it'll take them a few molts, I'm sure.
Oh,
But,
yeah.
Yeah, that's crazy.
Yep. And also you'll have to break the claw off in a particular area or they'll bleed out, which I didn't know crabs could do. But
I guess that makes sense.
Yeah. So, the stone crabs feed on oysters and other mollusks and crustaceans. They also, on occasion, will eat seagrass. Probably not their favorite thing, but, they eat whatever. Predators include horse conch, grouper, sea turtles, cobia, and octopuses. And the cool fun fact I wanted to talk about, that I was doing some digging on stone crabs for my PhD research, and in this NOAA document, I came across something called stridulation.
Yeah, that's a very just fun sounding science word.
It's basically like the rubbing together. It's almost like, I think it's what crickets do too.
Yes.
It's like they're chirping. In this NOAA document about stone crabs, it says like the adult crabs stridulate, and it's been reported to be occasional and erratic, but no one really knows why they do it. Although some fishermen believe that crabs talk or stridulate during mating season. So, that I found very interesting, specifically because their mating season is September to November, and I just happened to put out some acoustic recorders for my research last week. So,
cool.
Will I hear some stridulation of crabs? I hope so. That would be so cool.
That'd be awesome. I think we know we're in for the next Seagrass Corner if that happens.
Yeah,
absolutely. Yeah, send me that audio file.
Okay. Well, first I have to figure out what it sounds like, because I don't know what I'm looking for.
Yeah, I imagine it would sound different than a cricket for like a number of reasons. One, I assume these are like fairly substantially bigger if they're big enough to be taking their claws for meat, you know.
Yeah.
And it's underwater, obviously that changes things.
Yeah.
But yeah, the way stridulation kind of works, like, have you ever heard somebody play a washboard, like in an old timey movie or something?
Yeah.
That's basically what it is, where it's like it quickly moves from like ridge to ridge. So it's basically like moving something hard over like another hard thing that has ridges. So it like jumps from ridge to ridge really quickly.
That's cool.
Neat. I'd never heard of a stridulating crab though. That's really cool.
I know, me neither. And I really hope this goes somewhere because that would be cool.
Yeah.
Fingers crossed. All right, speaking of things that hope they're going to wind up cool, Gavin, what are we talking about today?
Yeah, so with our sort of opening segments and chit chat of the podcast out of the way, let's talk about some swamps. As I mentioned, before Fia moved to Florida and switched over to studying seagrass, Fia's opening segment of the show was called Swamp Corner. So I figured for this sort of honorific Fia episode, we're going to talk about some swamps. So first, I'll ask Mike first and then Fia. What is a swamp?
God.
Or I guess I'll give you a little more specifics here. What is
a swamp?
What makes a swamp different than like a marsh or a bog or other types of wetland?
See, you made it worse because I was gonna be real general here and just kind of lump all those things together.
Do what you got. I'm gonna lump them together for reasons I'll explain later, but they are different. So I guess
okay.
Yeah. So how would you define a swamp?
Okay. So again, loosely defining swamp here to possibly include some of those other things here. Number one, for me, one of the key features is that it's got to be very wet.
Okay.
Like I'm trying to think here. How, like, is the ground just damp? Is there actual standing water? I'm going to say there has to be like what you would consider a standing body of water, not just that it is like, wet and soupy in the ground, but like there has to be actual water that like a person could at least go part of the way down in.
Okay.
Gotta be like, no permanent human activity being built on it. Swamp. I'm struggling with this one. This is definitely one of those I know it when I see it, or at least I think I do.
Yeah, exactly.
But yeah, help me out here.
So, Fia, what are you thinking?
Yeah, so I'm actually taking a wetland and water quality class this semester.
I love that for you. Maybe you can help me out a little bit throughout the episode.
Oh, no, I still have yet to learn anything about anything.
I was going to say, it's like the second or third week?
Yeah. We're talking about the carbon cycle right now. But,
gotcha.
Yeah. So a swamp is a type of wetland and a wetland. So, sorry, my brain is turning too fast. A swamp. It's got water in it at some point of the year. It doesn't have to be all the time, but it's got to have water at some point. And I believe that swamps are so between swamps and marshes and like all this stuff, it's all different based on like the vegetation and like the species that are growing there. So I think that swamps, I know marshes are like softer plants, and then I think swamps are like woody plants, like trees.
Yeah, that's exactly right. So swamps are hard woody plants, trees, shrubs. Oh, Mike.
What are you laughing at?
Being a child.
Nothing. I don't know what you're talking
about. And then marshes are herbaceous plants. Things like ferns, cattails, horsetails, stuff like that. Those are sort of two different... There's lots of areas of gray in between each of these, but there's generally 4 different types of wetlands. There's swamps, marshes, bogs, and fens. We'll talk about...
Never heard of that last one. I think you made it
Most
up.
people haven't, so don't feel bad. They're very similar to bogs. We'll talk about it in just a second. Not a main focus of this episode. But yeah, so basically a swamp is an area with basically, extremely saturated soil. So it's very wet. The soil cannot hold much more, if any, water. And it has to be forested. So there has to be woody plants make up like sort of the majority of the area. And ironically, if you want like a good visual of a swamp, Shrek did a really good job, actually. Because, like, he lives in a tree.
Yeah.
If you think about it, he lives in a dead tree. And when you look at Shrek Swamp, there's, trees all around. And there is water, especially like in the opening sequence that we all remember. He like goes and, bathes in the mud and everything. And, if you just watch, if it, as weird as this is going to be to say, if you watch Shrek's feet as he walks around the swamp, he clearly, like, that is clearly like very muddy, not super firm ground. And that's because the soil is very saturated with water. So ironically, you don't think of Shrek being realistic for basically anything, but that is like a decent depiction of a swamp. Not all swamps. Swamps can have much more water. It sort of varies from time to time. But that's a solid depiction of a swamp. So then my next question was going to be, what is a marsh then? But we kind of answered that. So it's basically a swamp that instead of having woody plants, it has herbaceous plants, softer plants. And swamps are generally sort of inland of marshes. So if you were to look at like sort of a transaction from, inland to ocean, it goes like much drier land, maybe just like a typical forest, to then a swamp as you get closer to the ocean, or other body of water like a big lake or a river or something, where still trees, but now the soil is waterlogged. Then you get a little closer to the body of water and you have a marsh. It's too wet for any of those big trees to grow. And then you have the water. And so both swamps and marshes sort of, and we're going to be talking about them. The episode's just going to be called Swamps because it's easy. But we're going to be talking about all sorts of wetlands throughout pretty much the entire episode.
Cool.
But yeah, both swamps and marshes get most of their water from flooding, especially swamps, because like I said, it is sort of more inland compared to a marsh. They get a lot of their water from flooding and yearly increases in water level from their sort of host body. So like when a river floods, that's when, you get like the really tall standing water in a swamp. And you'll often hear sort of it differentiated, at least with marshes, where it's like, here's a salt marsh, here's a brackish marsh. It doesn't really matter what kind of water it is, but whether it's a swamp or a marsh, that is all about the plants. And there's different trees and stuff that, can tolerate higher or lower levels of salt. That all just sort of depends on, the local ecosystem. Stuff like bogs, on the other hand, bogs are more or less like ponds or small lakes that accumulate rainwater and runoff into a low-lying area. So they don't necessarily have like a host body of water like a lake or an ocean. They are just sort of like a pond or a lake themselves. And they get their water from rainwater, not from like a river or flooding or something. They build up dead plant material, and the water there is generally acidic. That's what makes it a bog, is that the water's acidic.
Whoa.
Huh, okay.
Fens, on the other hand, they get most of their water from upwelling of groundwater springs, often through limestone. And so because it flows through limestone, that chemically makes it alkaline or chemically basic, the opposite of acidic. So chemically, fens and bogs are very different, even if they look the same. If you were like on, the side of it looking at it, they'd look quite similar. The plants would be a little different because plants, different species of plants require different types of chemistry. If you do any gardening, there are some plants, like I know blueberry plants really like acidic soil. So there are different types of plants that live in bogs versus fens. But they get their water from a different place, and because of that, the water has different chemicals. Sometimes, one can sort of, like I said a little earlier, there's definitely like shades of gray between all of these. Over time, a bog can turn into a fen, or a fen can turn into a bog. As the coastline shifts, marshes can turn into swamps if the ocean recedes. Swamps could turn into marshlands if the oceans rise. Stuff like that, or even just like if the river shifts a little bit, if the river wiggles around, that can change whether it's a marsh or a swamp or neither. So these are all humans trying to fit stuff in boxes that they don't necessarily always fit nicely in. It's kind of a theme of science generally.
Yep.
So like I said, while this episode is generally going to focus on swamps, especially when we get into sort of the paleontology side of the episode, when I say swamp, I'm meaning generally wetland. Because especially once we look at the fossils, it can be hard to differentiate. But we'll talk about that later.
This is one of those things I imagine it's hard to tell, millions of years in the past, like what was a marsh versus a swamp. Right.
And it's like you can look at the plants to try to do that. But, it's not like there's a hard cutoff. It's like where, there's no cattails in a swamp. Like, no, they will be there if there's an area that is like maybe a little more waterlogged. But just because there are cattails, it doesn't mean it's one or the other, So it's if the only fossil you get is a cattail, that doesn't really tell you anything. Other than that there was water there.
Like you said, these are all shades of gray, so that makes sense.
So surprisingly, you might not think this, but the water in swamps is actually reasonably clean of at least pollutants. I want to be very clear, do not drink swamp water. You'll very likely get sick, but it at least will not be like pollutants that gets you. It'll probably be bacteria or things, because another big thing, especially of swamps, but also of marshes, is that the water is very stagnant. And it's easier for microbes and things to grow in stagnant water than it is in flowing water. But sort of the natural structure of a swamp just sort of naturally filters out bad chemicals, or especially like heavy metals like lead, arsenic, aluminum, stuff like that. It's very plant rich, obviously. So elements like phosphorus and nitrogen get sucked right out of the water into the plants. For example, those two, phosphorus and nitrogen, are the two main ingredients in fertilizer. So there's a big problem of like fertilizer. If it rains, fertilizer gets washed into a river and then goes out to the ocean. That's when things like red tides happen and kills off a bunch of fish and causes lots of bad toxic algae to grow. Swamps help prevent that from happening because they can sort of soak up some of this nitrogen and phosphorus before it gets out to the ocean. Because that water is very stagnant, those heavy chemicals, that if this was like a river or something, the flow of the water would be enough to get those moving through down the river. But because the water's so stagnant, the heavy stuff sort of settles out before it makes it out to the ocean or something. And then that stuff gets buried by like all the dead leaves and dead plant material. And swamps do a really good job of locking up these sorts of things, different elements or chemicals that are not great to have just out in the wild. Swamps do a good job of like locking that up and keeping it there. And the main reason that can kind of happen, other than like the stagnant water, is that the water tends to be very, very anoxic. The water in these places has very little oxygen in it, especially once you get like a little bit away from the surface. Mostly because just sort of the chemical process of breaking down dead stuff, mostly things like fallen leaves or tree branches and things, that absorbs oxygen. The microbes that do that suck up oxygen to do that. And so if you have, 5 feet worth of just fallen leaves trying to decompose all at the same time at the bottom of this marsh or swamp, that's going to like suck up a lot of the oxygen from that local water. And because of that, that means that less things can be broken down. And so at the bottom of marshes and swamps and things, it is a really good place to get fossils over long periods of time. Or if you've heard of like bog bodies or bog mummies, we'll talk about those a little bit more later. Little spoiler for you.
Mm-hmm.
This isn't always the case, though. There are some swamps that are quite productive and have a lot of fish and things swimming in them, especially a lot of what are locally called bayous in sort of around the Gulf of Mexico. Those tend to be the things that are called bayous. And Fia, please correct me if I'm wrong. You've actually, lived in places that have these. They tend to, things that are called bayous generally have, enough water to be like up to your chest. When I think of a bayou, I think of somebody going noodling, which is catching big catfish with your hands.
Is that a term that people know? Like
bayou?
I watched a lot of Discovery Channel.
No, not bayou, noodling.
No, I don't think that's a thing that people, like, everybody knows.
No, it's definitely not a thing everybody knows. But I watched a lot of like,
yeah.
I watched a lot of like river monsters and stuff as a kid around Discovery Channel.
Also, and what's that show with like the alligator?
Crocodile Hunter?
No. It's like a Louisiana-based like alligator hunting show.
Oh, okay. Yeah, I'm blanking on the name.
It's like Duck Dynasty, but...
Was it just Swamp People?
Yeah, Swamp People. Yeah. There's like one episode where they like go noodling in like Mississippi or something, and that's the only reason why I know. So, Mike, do you know what noodling is yet?
It is either a crude term for a act that I'm not familiar with, or it is catching catfish with your bare hands in a swamp, or both.
That is, I did say that earlier. Where
right.
Yes,
yeah.
And so it's typically referring to catfish, but I feel like in theory it could be any kind of fish. Okay, maybe.
Fia, can you make that noise again?
No, I can't.
Okay, so I guess it's pretty much just catfish then.
Yeah. I don't know what other... maybe carp, but no, they would. I just don't think they would bite you like that. I feel like it's...
Yeah, the trick is to get them to bite you. You're basically shoving your hand in their mouth, and they bite onto you, and then you pull it out of the water.
Yeah.
That's basically how noodling works.
Okay, anyway, a bayou. What my comment was going to be was that bayous, I think that this is not coming from any definition, but just off of experience. Yeah. A bayou is something that actually has a current or like a flow, and it's probably like not anywhere like that a river could be, but it has a little more. It's a little less stagnant, I think.
Okay.
But again, gray area, total gray area.
But yeah, like bayous, especially in places like Louisiana, Mississippi, Florida, they can be like extremely productive environments, but still generally have pretty low oxygen if you get more than, a few inches or a foot or so from the surface. That's why it's mostly things like, catfish, carp, things that are just very hardy fish that can live kind of anywhere. That's why they are sort of very well known for these areas. Obviously, there are other fish and things that live in those environments, but these areas can be very biologically productive. But they need, pretty hardy animals to make that happen.
Cool.
And
one fun fact I wanted to bring up about like this wetland kind of concept is that it's anoxic, right? Because like you need oxygen to like decompose matter, but like the further down you go in the soil, there's like other special bacteria that can use different compounds like sulfur or nitrogen to decompose, but it's way less efficient like chemically, and that's like why that's another reason why it takes so long for like all this organic matter to decompose, because there's still like decomposition happening. It's just like slow.
Right. And so if you remember back to, high school, maybe even middle school biology, there's aerobic bacteria that need oxygen. And then there's anaerobic bacteria that don't need oxygen. In fact, oxygen is toxic to them. And so a lot of photosynthetic or phototrophic bacteria, those are things that absorb sunlight and then release oxygen. There's also lots of chemotrophic bacteria that, and that's what some of these anoxic decomposers in the bottom of the swamps are. They, in the absence of oxygen makes life just like way more efficient, being able to process oxygen.
It truly does.
And so the things at the bottom of the swamp still can do the job of the aerobic decomposers, but they do it much more slowly. And something that a recently retired professor in my department here at Bucknell, something that he sort of worked on and did a lot of work with locally, is making man-made wetlands and basically forcing water through them in a specific way to get acid mine drainage. So like there's lots of abandoned like coal mines and other types of mines here in central and northeastern Pennsylvania, and as the water flows through them, it becomes acidic, and then that gets into the river and then get into like drinking water, and that's obviously a problem. Along with, it has lots of heavy metals like aluminum and stuff in it like that. That's also bad. And so if you pump the water and sort of force it to flow through wetlands in a specific way, it's sort of like a tiered wetland, where it flows like down through a bunch of crushed limestone and peat, which we'll talk about later. It sort of gets those heavy elements out of it and turns it from an acid into at least more neutral, maybe not quite basic or alkaline. But by sort of purposefully directing it in these certain ways, you can make the water much safer to just be around. So there's lots of cool, like, practical ways that this knowledge is being applied all over the place.
Cool.
And then lastly, I guess a couple more things. I wrote lastly here, but then I added something later in my notes. Swamps themselves are kind of loosely region restricted. Swamps specifically tend to be located in more tropical or subtropical regions. Some of the largest swamps in the world are in places like the Amazon River Basin in South America, the Congo River Basin in Central Africa, Indonesia in sort of, Oceania, part of Asia. However, there's also some pretty large swamps in places like Illinois, by no means tropical. Russia, by no means tropical. Slovakia, Southern Australia. Basically anywhere there's a pretty large body of water and a climate that's conducive to trees existing, which isn't all environments, but anywhere you have those two things, you hypothetically can get a swamp. So what kind of critters can we find in a swamp? When I think of a swamp,
Ogres?
I guess, Mike, what was that?
Ogres?
Yes, my first thoughts are ogres and donkeys.
Yeah.
So, Mike, when you think of a swamp that's not from a movie, what's the first animal you think of?
I mean, we said like alligator crocodile before. So either actually no, I'm gonna change my answer.
Okay.
To the swamp rabbit, because I am familiar with Jimmy Carter's presidency.
That's new to me. I've never heard that one.
The Jimmy Carter swamp rabbit.
I'll have to look that up. I am a
just look at it. It's like
okay.
I'm not gonna go into it. Look it up. It's it's Jimmy Carter.
Sure. But the real answer is basically anything. For example,
you trick you.
Yeah.
God, there's words I'm not allowed to say.
For example, white-tailed deer perfectly happy in a swamp. They're all over the place. They can live pretty much anywhere. In places like all the various swamps around Asia, all sorts of different deer and antelope are perfectly happy in swamps. There are even like swamp specialist deer and antelope. So just because it's, not lurking in the water doesn't mean it's not perfectly happy in a swamp. That being said, most of the animal life does sort of revolve around the water. That is sort of one of the main features of swamps. Animals that are at home in somewhat murky, stagnant water are happy in swamps. Things like crocodilians, snakes. For example, some of the largest snakes in the world. Anacondas. Some of the pythons in Asia. They love living in swamps. That's kind of the anaconda's whole thing, is being an aquatic predator because they live in swamps and marshes. Even some things like some cats are pretty water adapted, like jaguars. They are very happy in the water. And so they live in a lot of swamps. Jaguars? What was that?
How big are jaguars?
They're pretty big. They're like
golden retriever.
I'm trying to think of like I'd say even probably bigger.
German Shepherd.
Not like a ton bigger. Yeah, like German Shepherd-ish. Like not as big as a lion, but like not. I'd say between a German Shepherd and a lion, I'd say on the closer end to a lion.
Okay.
They're big. They're like, not that this will help you, Mike, I don't think, unless have you seen a mountain lion in person?
I have not.
Yeah. I was going to say, like...
I've seen videos of them.
Like a stockier, more muscular mountain lion.
Yeah, okay.
Maybe a little bit larger, but not hugely. They do overlap in location in a lot of places.
What is the percentage chance that if I got in a fight with a jaguar that I could win?
0.
Okay.
They
you want to think about that answer for a second, maybe, or
not even a little? And it's not because of you. So their whole hunting strategy is they crush the skulls of whatever they eat, including like in South America and places, they will eat crocodilians. And they will crush the skull of crocodilians and just kill it that way. Yeah. So no, I feel very confident that there's basically no human like unarmed that could, beat a jaguar. That's just not a thing.
Understood. Okay.
But yeah, and then obviously there are things that you think of with swamps as well, stuff like mosquitoes and other insects that like stagnant water and need that to breed. There are lots of birds who love swamps. There's, thousands and thousands of species that are like swamp or wetland, specific. There are some, like I think, I want to say you've actually talked about these on the pod before, Fia, but roseate spoonbills.
Oh yeah, my favorite bird.
Yeah. Them and like flamingos are sort of similar, where they eat like microscopic or at least tiny things living in the water, little crustaceans and shrimp and things like that. So that's sort of the creatures hanging out in the swamp, but that's not exactly what we're here to talk about. We're here to talk about the plants for a change. Snuck up on you. This is a plants episode. And then actually, finally, before we get into some of the paleontology, let's talk about swamp conservation. Humans really hate swamps because we can't build houses or feed cattle on them. So we drain them and we destroy them.
Yep. It's like a ridiculous amount that we've lost in the United States.
It's crazy. And like in some places, it has also been like a preventative measure for preventing disease from mosquitoes. Like there's some places in the global south that have drained swamps because like mosquito-borne malaria is just such a huge problem. So like in those instances, like I get it, but at least for the most part in the global north, we do it because you can't build a house or feed a cow on a swamp.
Yep.
Another thing that we do that's really bad for swamps is we put up levees along rivers to stop them from flooding the places where the swamps used to be. Because if a swamp was there, it would just absorb all of that flood water. But because we got rid of the swamp, now there's nothing that does that for us anymore. So we have to build higher and higher levees along all these rivers. And so even if there's an area of swamp that didn't get paved over, because we built up these levees around these large rivers, like especially the Mississippi here in North America, that just like chokes off the swamp from the water that it needs to actually function as an ecosystem.
Levees are my pet peeve of the South.
Yeah.
They're just
Really?
so infuriating. Yeah. Just because I lived in Louisiana and like the change in like
they've historically had some trouble with levees, as I've heard.
Yeah. It just like the sediment accumulation, like because it's all just channeled into one thing, means like, or one like main river, the Mississippi.
Right.
Like the rest of the state's coastline is just degrading without getting any like supplemental material to build it back.
Yeah. And so, like, if the river were able to flood like it normally would, all of that sediment would get dispersed into these swamps.
Yeah.
And kept there. But because we put up these levees and we no longer allow the river to flood like it's supposed to naturally, all of the sediment gets shunted down into, like, one specific spot.
Right.
And then the other places that need it, the coastline is just receding because there's no, like, new sand being replaced. So it's basically like, you know, if a kid with a dump truck toy scooped up all the sand from like a bunch of beaches and dumped all of it in one spot.
Yeah.
But
Cue Led Zeppelin, I guess.
That's a reference I don't understand.
They've got a song called "When the Levee Breaks."
Oh. Nice.
All right.
Yeah, anyways.
Yeah. But all over, and this, we've been talking about North America just because that's, you know, what the three of us are most familiar with, but swamps and wetlands all over the world are struggling pretty just across the board. Especially along coasts, swamps and wetlands, you know, kind of act as like a buffer for pretty much everything. They act as natural levees and soak up floodwater, or I'm blanking on the word for like a storm surges, like when a hurricane comes. Normally wetlands would sort of act as a buffer and soak up some of that water, but we got rid of them, so nothing does that anymore. And they also help prevent saltwater intrusions inland when big storms happen. So, for example, like when farmland, not as much cattle farmland, but especially like crop farmland, when that gets salted, it basically just ruins the productivity of that farmland for generations because the plants can't grow there because there's salt water there. And so having swamps as a buffer is just economically useful to farmers, let alone just like how the nature is supposed to be. So like there are reasons to have the swamps there other than just, you know, nature being nature. It's like there are economically useful reasons for this to be, you know, the case.
Yeah.
As I mentioned, they also do other useful things like trapping arsenic and lead and stuff out of water. Mm-hmm. In the 70s, wetland protection actually started gaining some traction. In my notes here, I have in parentheses another weird Nixon W. There's a lot of things that like Nixon did that were actually kind of good. Right. And it's like I'm always
and then you
surprised.
hear that tape that came out last week and you're like, oof, not everything.
Yeah, no. I don't even know what you're referring to, but I assume it said the N-word a whole bunch.
Not like out loud, but you know, he meant it.
Yeah. But yeah, so like the Nixon administration did some surprisingly cool things with environmental policy. But in a lot of cases and places elsewhere in the world, the damage was kind of already done. So for example, New Zealand, this place that, you know, people who've seen Lord of the Rings picture as like this beautiful landscapes, pristine nature. Over 90% of wetlands in New Zealand are gone. And New Zealand is one of the most unique ecosystems in the world. So, like, a lot of things are gone that just can't ever come back because it's an island. There's lots of things that are unique to there. Europe has lost half of its wetlands, even with some projects to help start bringing them back. Whole states here in the U.S., such as Fia's two adoptive homes, Louisiana and Florida, should normally be almost entirely covered in wetlands.
It's so bad.
Yeah, so like the whole states really should, if pre development, should be various degrees of swamp, marshes, etc. But now there's like 22 million people that live in Florida.
A lot. There's a lot of people.
And so this causes a lot of problems for the people who now live there because these ecosystem services are no longer being done. That buffering of storms, no longer being done. That sort of regulation of flooding, no longer being done. And so just as a little PSA, we're getting pretty close to election season here in the U.S. If there's a candidate who cares about environmental issues, consider voting for that person. If you also care about those issues, if you get a chance to talk to somebody running for office, especially some of the more local offices, ask them about their plans to protect your local wetlands. And if they don't have an answer, don't take that as an answer. These wetlands do a lot for us, and we need to support them and elect people who support them.
Preach.
Thank you. Cool. So that's modern swamps. Let's talk about swamps through time. And sort of a segue here into talk about swamps in the past. The main thing that a paleontologist thinks about when they think of swamps and other wetlands is a substance called peat. P-E-A-T. And so peat is basically compressed plant matter that doesn't get properly decomposed because of that lack of oxygen in the water, and it just sort of piles up over time. Peat is the first step to the formation of coal. And we talk all about coal and other fossil fuels way, way back in episode 27. I'm pretty sure that was like mid-2021 sometime. So in the context of this show, a long time ago. So let's talk about coal. Coal is compressed plant matter that builds up over time and gets buried and compressed and heated underground. And sort of that heat, mostly heat, but also some pressure, sort of pushes out all of the non-hydrocarbon materials. And the lighter, or the higher the heat, the higher grade coal. So in that sense, it's the highest grade coal is mostly considered a metamorphic rock. If you remember, we had an episode about the rock cycle at some point as well. Metamorphic is like the kind that you typically see around mountains because you need high heat and high pressure, and it sort of transforms other types of rocks by that heat and pressure sort of moving around the atoms and forming new minerals in weird ways. And so there are generally 4 types of coal. There's lignite, which is the least heated and pressurized, subbituminous coal, bituminous coal, and anthracite, being the purest coal, somewhere between 86 to 97% carbon.
Wow.
Yeah. Ironically, though, coal, and this is anytime I talk about coal, I feel like I should mention this. You can't make a diamond out of coal. That's like a common phrase, is like, pressurizing a coal and making a diamond or something. That's like a common thing you see in just like media. That's not how diamonds are made. That's not even really how synthetic diamonds are made. Anyway, but the area that I live in these days, sort of central and northeastern Pennsylvania, specifically sort of the areas around Scranton, Pennsylvania, have the highest reserves of anthracite coal, that really high-grade coal, in the entire world. And anthracite is quite rare, all things considered, and it's often sort of found with lots of other plant fossils, but anthracite only makes up about 1% of coal globally. So this is like a very productive, historically anyway, region for coal. Coal is obviously best known as a fossil fuel, and because of that, it's often found with plant fossils that give a pretty good picture of the types of plants that are, that were around at the time the coal was buried. Peat, as I mentioned earlier, talked about like bog bodies or bog mummies. You might have heard of this from like certain northern countries like Canada, England, some places in like the Balkans and in Scandinavia. And this happens when there's like, sometimes it's like a person from like medieval times or sometimes even earlier who just like died and like, or like fell in or got trapped in the bog. There's, I think, been a couple cases where I think it might have been a burial practice of some kind. But these people look like they just died yesterday.
Yeah, that's so cool.
Yeah, because they just fall.
I've definitely seen like animals that have gotten trapped, like, or like half in and half out, and it's wild.
Yeah, because there's none of the things, or at least, the things that can decompose them are just way less efficient at it. And, you could store a body in the bottom of a swamp for hundreds of years and then pull it out, and it looks like they just, like I said, just died yesterday. This occasionally happens with, non-human animals, and from much longer ago. It's very tricky because the chemical conditions that are good for making plant fossils are bad for making animal fossils, generally.
Yeah.
Mm-hmm.
So it's pretty uncommon to find animal fossils and plant fossils in a certain place, like sort of on top of one another. But it occasionally happens in what have been interpreted to be ancient bogs and things, with some pretty spectacular results. There's a few cases of dinosaur mummies found in what likely used to be bogs when they were around. These days it's in places like Canada, like central Canada, some of the dry places, Alberta specifically. There's been a couple that have been found in there. But yeah, some of these dinosaur mummies come from like some pretty arid places today, so that just kind of is sort of a good juxtaposition of how climates change over time. But specifically, though, there's been a couple pretty famous ones like kind of recently. Both have been, I think, nodosaurs, or at least ankylosaurs, somewhere in that group. Basically, like the sort of low-sitting, like armored dinosaurs, like ankylosaurus, the ones with like bony plates on their backs that aren't like stegosaurus. So some of them, they're pretty famous because they it's hypothesized that they float in the water a certain way because their whole back is covered in like dense bone, while the rest of their body is less dense. So they like sink a particular way that has been hypothesized, because we had a couple like in pretty close succession, like really spectacular fossils found, and it's like, okay, why these? And just scientists speculating and things, but so occasionally it can happen. Also, sort of around marshes and coal deposits, some of the best fossils in at least northern South America come from the Cerrejón Formation in Colombia, which is mined very heavily for coal. And some of the fossils from around this sort of area come from, or include fossils such as the very famous enormous snake, Titanoboa.
Oh.
Mm-hmm. We've talked about that before.
Yep. So this is basically an anaconda that was sort of scaled up to be about 40 to 45 feet long. There's also a type of giant turtle found from these fossil deposits called carbonemes, which means coal turtle. It had a shell about 6 feet long, so like a turtle, the size of like a dinner table is often what it's compared to.
Wow, that's huge.
Yeah. And so these fossils weren't found like in the coal itself, but in some like sediment layers between the coal layers. And so the Cerrejón Formation is like very well known for some of these fossils and for its coal. It's also very well known because the local indigenous people have been very negatively impacted by these coal mines. They actually had sort of a documentary about it that they showed here at like the campus theater a couple years ago that I went to. I don't remember the name of it, but it was worth a watch. It was really interesting, and also just sort of pointing out that cool fossils are not worth human suffering, as that happens to be an unfortunate theme, that comes up every now and then about really cool fossils, unfortunately. Cool. So let's now actually go through some of the history of swamps on Earth. So technically, swamps, like true swamps proper with the woody plants, technically could not form at all until about 400 million years ago. Because, so that was in the Devonian period, and that's when we get the oldest wood that we know of in the fossil record. And you need woody plants to make a swamp. So, by definition, swamps could not have existed before about 400 million years ago. And plants had come onto land about 70 million years before this. So there could be wetlands, there could be marshes, but not true swamps. And there's also some other very tangentially related things. So like certain types of rivers also just couldn't have formed because their flow is sort of constrained by woody plants and their roots. So like there's really interesting like geomorphology types of things that are, focused around the evolution of different habits that plants take. Basically, for the rest of this segment, though, I'm going to be talking about swamps and wetlands sort of interchangeably, not differentiating, because it can be really, really hard to know for sure that an area was a swamp in the rocks. So basically, we use coal as a proxy. That's why I talked so much about coal just a bit ago, because most of what we know about ancient swamps comes from coal. And coal doesn't necessarily mean swamps specifically. Coal can form in other types of wetlands too, but it's a pretty good proxy for wetlands in general, and we can tell the difference between certain types of plants, whether it was woody or herbaceous, based on the fossils we find in the coal. But whether this was just like the one tree who happened to grow in this marsh, unsure. And so the earliest concrete evidence of swamps comes from the coal deposits from the Devonian period, especially toward the end. So this is, sort of in the high to mid 300 million years ago or so. And so the Devonian period ended with a big glaciation, potentially caused by the spreading of these swamps, which locked up tons of carbon dioxide and dropped global temperatures considerably. The global cooling then caused a lot of these plants to die off all at once. So there was just a lot of dead plants, basically all at the same time. And it's really important to note that at this time, there really weren't any microbes like fungus or bacteria that could break down lignin, which is sort of the main hard component of wood. Wood was still like a pretty recent evolutionary, innovation. And so the typical decomposers at the time hadn't yet adapted to be able to break it down. So when a tree died and fell into the swamp, it couldn't be broken down like it is today. So when basically an entire globe's worth of forest dies very suddenly, and there's no decomposers to break it down, it all just kind of sits and gets buried and turns into coal. And so that's, separate from the anoxic conditions that swamps normally get, From the Devonian period, we then move into the period literally named after an environment from this time called coal swamps. It's called the Carboniferous period. See episode 81 for that. And the element carbon is named after the Latin word for coal. So Carboniferous literally means the coal-bearing time.
That's interesting.
Yeah. And so the Carboniferous period lasted from 359 to 259 million years ago. And it's, at least here in North America, also sort of split into two smaller stages called the Mississippian and the Pennsylvanian. Because we have a lot of rocks from, this time period in Mississippi and Pennsylvania. And so especially during the Pennsylvanian, which is sort of the second of the two, closer to the end, much of the continents were covered by an ecosystem that are called coal forests. Basically, everywhere that was warm enough to have a large forest had these swampy ecosystems occupied by stuff like large amphibians, early amniotes, so the first types of animals that laid like shelled eggs, and also large arthropods, things like giant millipedes, giant dragonflies, large spiders, things like that. And so the global climate in general at this time was very humid, and so global precipitation was also pretty high, and it created these sort of swampy environments a little further from bodies of water than we might expect to see them today. And there's also evidence that, global elevation, just in general, just the height on average of the continents was lower. So there were these big basins sort of all across the world that, formed these sort of low-lying, swampy areas that water would accumulate in. And so, just these giant bowls of earth, and they were also subsiding at the time. So getting sort of pushed down into the earth. And so they would fill up with plant material as the earth was subsiding. Think of sort of like a golf ball, how it has like the divots. If the divots were being slowly made deeper, but then getting filled back in with like dead plant material. And then, like I said, during this time, the Pennsylvanian, there was a lot of weird global climate things going on, because this was when Pangea was coming together. This caused some weird sea level rise and fall off and on, and with these plants soaking up lots of carbon dioxide and then not releasing it back into the atmosphere again, this caused some more glaciation, just like in the Devonian. And when there's a lot of glacial activity, sea levels change pretty drastically. Not just in one way or the other, but they tend to fluctuate quite a lot. So basically, as the sea levels fell, the swamps would then sort of migrate to keep up. And then when sea levels would rise, they would cover those new swamps back up and bury them. And this would happen over and over and over. So this is a great way to make swamps, because not only are you getting a lot of plant material, you're then burying it with sediment really quickly.
Yeah.
And that sediment sort of traps it there, and it pressurizes it, and because it's, getting closer and closer to like the center of Earth, it just gets warmer. And so this is a great way to make coal. This is really why, a major part of why we have so much coal from this time. And then so once we get into the Permian period, the next period, 299 to 252 million years ago, episode 89 for more, things change a little bit. The Carboniferous ended with a large glaciation, like I mentioned, and this glaciation sort of continued for several million years into the Permian. But in general, the Permian is sort of broadly seen as being a pretty hot and dry time in Earth's history, especially as you get toward the end. And so then if it's generally seen as like at least a very dry, global temperatures and overall in the Permian were kind of low, but why do we see a ton of coal from this time too then? Because most of the coal that we have comes from the Pennsylvanian, but then also the Permian as well. And so Pangea generally was kind of shaped like the letter C, with the very bottom of the C being pretty near or on the South Pole. But the middle part of the sea was kind of near the equator. Including sort of like the ends of the sea, the parts that like kind of almost come together to form an O. That was kind of around the equator. And while, yeah, the interior of Pangaea was very dry and very far from the water, places, if you've been there, if you're imagining it, places sort of similar to like Montana or Utah today, that sea shape, especially having an ocean in the middle of the sea, that makes just a lot of coastline. And so there's still just a lot of room for swamps as well. And so some places, especially that middle part of the sea, had quite a lot of precipitation. So what is now Northern Africa and Southern Europe, they were sort of on the middle of the inside part of the sea. And, they sort of got like a lot of precipitation sort of channeled into them because it almost sort of made like a funnel. The way we think the prevailing winds sort of blew at the time, blew just all the moisture from the sea into like this one spot. So we have a ton of coal from this time from these spots.
Cool.
And then those glaciers that ended the Carboniferous period, those were still happening in the Permian, causing lots of sea level activity. So that continued throughout the early parts of the Permian as well, just sort of lowering sea levels, growing more swamp, raising sea levels and burying them, and etc. Then at the end of the Permian, there's a real bad extinction that we talked about in that episode 89. The worst mass extinction in history. Killed like 96% of all species on Earth.
Seems bad.
Real bad. And we call it the Great Dying, very affectionately. And so, in general, plants tend to weather mass extinctions quite well. This was one of the exceptions, where plants really kind of struggled through this. And this extinction was caused by massive volcanic eruptions over a very long period of time, releasing lots of CO2 into the air, raising global temperatures really, really high, really fast. Sounds familiar. And this was just really not good for the plants. So much so that once we get into the next period, the Triassic, episode 98, there's a period of time at the beginning that we call the coal gap. And so, as it probably sounds, this is a span of time, around 6 to 10 million years or so at the start of the Triassic, where we just don't get, like, any coal. Oh, or at least, the coal that we do have is, like, very thinly bedded, meaning, so it's not like these giant, like, walls of coal like you see in some places. And that kind of means that if there were swampy wetland conditions, they did not last for very long. And this could be for a couple of reasons. Number one, we just don't have a lot of rocks from that time. There's just not much. So it could be that there were swamps and that would form coal. We just don't, all those rocks are gone. Global sedimentation rates at this time were really low. So the swamps may have been there, but there was no sediment to bury them. There were no glaciers to sort of mess with sea level in that way that would bury them nicely like there used to be.
Mm-hmm.
Or it may just have been that it took woody plants, just that long to recover from that extinction. So it could be a real thing. It could be bias. It's always kind of hard to tell, sampling bias from the fossil record. However, when they did come back, not super long into the Triassic, with the exception of kind of a downward blip in the middle of the Jurassic period, coal and coal swamps have been kind of a mainstay of global ecosystems, basically, to this day. Especially in sometimes like the late Cretaceous into the Paleocene and Eocene. So this is, when the dinosaurs went extinct, and then the 20 million years or so after that. We've talked all about those couple times in some relatively recent episodes. And so global temperatures were very high, global precipitation was very high. Plants were just in general living their best life. So, for example, at the end of the Cretaceous, Wyoming and Montana today, they were covered by this big seaway. And toward the end of the Cretaceous, it was sort of retreating. And again, it was retreating like in pulses. So it would retreat, swamps would follow it, then it would expand back a little bit, bury those swamps, and then retreat again. So that's why places like Wyoming and Montana have a ton of really good coal that all date back to this time, not from the Carboniferous, like you would kind of expect. And then, sort of wrapping up here, as with everything with plants, it is pretty obligatory to mention that during the Cretaceous period, the entire plant landscape kind of changed. As angiosperms, the group of plants that are called flowering plants, this is basically any kind of plant you can think of, they basically took over the world and replaced gymnosperms, or conifers, things like pines and firs and things like that. The flowering plants sort of took over basically everything throughout the Cretaceous and then into the Paleocene and Eocene. And this includes ecosystems like mangroves, cypress trees. Both of those are very iconic types of plants that are found in marshy wetland areas. And those are flowering plants. And so some other sort of relatively recent coal-bearing places include that Cerrejón Formation in Colombia. That was only about 60 million years ago. A lot of the Arctic coal in places like Norway, Canada, Russia, that's also pretty young, about 60 million years ago. And then even though we don't call them coal forests, places like the Amazon or the Congo River Basin, I feel like if, we were looking at what their fossils will become, human influence removed, I don't see why we wouldn't call those coal forests. And so coal and swamp ecosystems have been sort of a mainstay basically any time that Earth isn't, covered in desert. And so they've been also, as you can probably imagine, with talking about places like the Amazon and the Congo, very rich places of diversity, not just for the plants, but for the animals that live there as well. And that sort of brings us to the modern day and is sort of wrapping up our conversation here.
Cool.
Yeah, I feel like you should have a couple of just like fun facts, or like, hey, did you know this? Just to kind of throw in the end here.
I feel like I sprinkled my fun facts in the beginning.
Yeah, that's fair.
I don't have anything off the top of my head.
This was definitely like a plant-heavy episode for us.
I know, and I sort of did that to myself, like in a sneaky way, because famously, I don't like plants. They confuse me, but I do understand ecosystems better, which, like, I don't understand how that is, because ecosystems really are all about the plants. At least terrestrial ecosystems. So this was a way for me to, like, trick myself into doing a plants episode.
You nailed it.
Why, thank you.
And thank all of you for listening. This has been episode 100, and I'm going to go 45.
Yeah.
You got it, dude.
A podcast about things that used to be alive. My name is Mike. That was Gavin and Fia, and we'll see all of you here in 2 weeks for our next episode. Take care, everyone.
This episode of I Wish You Were Dead was written by Gavin Davidson and hosted by Gavin Davidson, Mike Bryson, and Finella Campanino. It was sound edited and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.